Welcome to C.6.4. Today we're going to outline the principles of liquid crystal display devices, and this is really what everybody thinks about when they think about liquid crystals. So we have to first realize that the ability of liquid crystal molecules to transmit light actually depends on their molecular orientation. So for example, what we have here is basically two plates of glass and then our liquid crystal in between. And what will happen is one of the glasses will have the sort of etchings in one direction, and then the other one will have etchings in the opposite direction. And what will happen is these rod-shaped molecules will align with the grooves on both sides, and then through intermolecular forces they will sort of transition in a twist from this vertical one here to this horizontal one here. So what that can do is at this point it can let light pass through. But what would happen is if we actually apply a voltage across this pixel, we can actually disrupt this twisting motion to the point where it does not allow light to pass through. So right now light can pass through. If we disorganize this twisting structure, then light cannot pass through. So what does that look like? Well, if you look at an LCD display under a microscope, and so you could do this with a high school microscope, or you can put a drop of water on an older phone and you can even see it there, but now the pixels are quite small and you can't really see it with just a drop of water. But what you can see here is here are the pixels that are on, and each pixel is 3 colors because the 3 colors can make the range of other colors, and we can turn on and off each of those colors with this sort of idea. And so what you can see here is, for example, text. In this text we would have applied a voltage that would disorganize the structure, and therefore the light underneath this pixel is not being allowed to pass through and we can't see it. Whereas once we can see right now, they would have the twisting structure.